Start recording. Okay. So last lesson we completed for uh, P P3. Okay, trigo. Okay. So P3. Let's try. We're not going to do the entire thing of P3, but you need to know what are the topic of P3 that is actually required for your FP1 later. So we have chapter 1. Okay, we have algebra. Okay, we have chapter 2, we have exponential and log. Okay, we have chapter 3, trigo. Okay, we have chapter 4, differentiation. We have chapter 5, integration. Okay, we have chapter 6, numerical methods. Okay, chapter 7, differential equation. Chapter 8, a vector. Chapter 9, this is a complex number. Okay, so we will need to do this is already done, this already done, this already done. Okay, the next we need to know, we need to complete this, we need to complete this, we need to complete this, we need to complete this. Okay, so okay, I'll try my best to actually work out the syllabus. Okay, next we go for differentiation, number 4. Okay, chapter 4, differentiation. Okay, first of all, let's go back to the basic rule. Okay, basic rule. Basic rule, we have a first principle. Okay, first principle. dy dx equals to limit of h tends to 0, f of x plus h minus f of x over h. Okay, number 2, we have the dx of fx plus minus gx. Okay, equals to the dx of fx plus minus the dx of gx. Okay, number 3, the dx of k times of fx, so equals to k times of the dx of fx. Okay, number 4, we have the dx of constant that actually goes to 0. Number 5, we have the dx of uv. Okay, go to u prime v minus v prime u, plus v prime u. So 6 gives u over v. Okay, so we have u prime v minus v prime u over v squared. Okay, or 7, chain rule. Okay, so we have the dx of f gx equals to f prime of gx times by g prime x. Okay, or dy dx is in the form of dy dA times dA dB times dB dC all the way to, okay, maybe dz dx. Okay, it depends on how many chain that we have for the questions. Okay, so over here these are some basic rule. Okay, for further math students, of course, everything here can be proved by using first principle. Okay, can be proved using first principle. Okay, but of course, for those students who are going for top tier university, or maybe going for the university interview, maybe you need to prepare for this lah. Then for others, maybe you are not required to. Okay, so these will have the basic rule. Then comes to basic differentiation. Basic differentiation. Okay, basic differentiation. So over here, basic differentiation, this is number 7. Then we have a number 8. Okay, number 8, we have d dx of x power n, bring down the power minus by 1. Number 9, d dx of ex equal to ex, or d dx of e fx equals to f prime x e fx. Number 10, we have d dx of ln x equals to 1 over x, or okay, we have d dx of ln fx equals to f prime x over fx. Number 11, we have d dx of sine x go to cos x. Okay, then number 12, d dx of cos x go to negative sine x. Number 13, we have d dx of tangent x go to secant square x. Okay, number 14, we have d dx of this one tangent secant x go to secant x tangent x. Okay, 15, d dx go to cosecant x negative cosecant x cotangent x. Okay, maybe we have 16. Okay, d dx of cotangent x goes to negative cosecant square x. And 17, we have d dx of arctangent x, okay, equals to 1 over 1 plus x squared. For your information, this 17, okay, this fall under new syllabus, the 2020 syllabus. Therefore, you may not find this question. You may not able to find this question from the old past year. Okay, you may not able to. So among these 8 to 17, okay, this one will be proved by first principle. Okay, this one will be proved by first principle. Okay, this one can be proved by first principle. Okay, the others can be appear as questions that in P3. Okay, the others can be appear as a question in P3. So it's very common that students need to know how to do these questions. Okay, they know how the proof, the reason why you actually get all these different rules. Okay, let's go for number 9. Okay, let's look at number 9 first. Number 9. Okay, d dx of ex. Okay, why is it equals to ex? According to the definitions of ex, okay, from chapter 2, okay, ex read as limits of n goes to infinity for 1 plus x over n power of n. Okay, so over here, the limit and the differentiation, we switch position. Okay, and the dx, okay, I differentiate the expressions of 1 plus x over n and n here. So what you can get is, okay, I bring down the power minus by 1, multiply by differentiate of the inside. So you will see that the limit of n goes to infinity. You have a 1 plus x over n power of n minus 1. So since this is in the form of power of n minus 1, compared to the definition of ex, which is power to n, okay, this n minus 1, then they are the same or go up to infinity, is actually show no difference at all. Therefore, this is actually same as ex. Okay. Then from number 10, okay, from number 10, so why the ln x goes to 1 over x, okay. So first we let y equals to ln x, okay. So you can see that y according to exponential and log, x will be equals to e power y. So now I do d dy for both sides. Okay, d dy. Then you will see that I have a dx dy. And differentiate of ey according to rule 9 is just ey. Okay, but this one only help us to get dx over dy, but what I supposed to get is to get dy over dx, so I flip them upside down. Dy over dx become 1 over ey, and we know that ey here equals to x, therefore it's 1 over x. This is the reason why you have the formula 1 over x here. Okay, number 11. Okay, by definition, by first principle, so d dx of sine x. Okay, according to first principle, we have limits of h tends to 0 of sine of x plus h minus sine of x over h. Okay, so okay, from trigo you just learned about the a plus b formula, so let's try to write them out. Okay, so I will sine a cos b plus cos a sine b minus sine x over h. What actually happened is, okay, the angle that we're referring here are all in the form of radian, okay, in radian. Okay, then sine x is just sine x, but the cos of x h here, cos of h here, since h is a very small number, if you press your calculator in radian, you'll find that it become 1. And the cos x here, okay, just cos x, the sine h here, if you press into the calculator in radian mode, it will just equals to h, it will equals to itself, then minus sine x over h. You will see that the sine and the sine here get cancelled off, the h and the h here get cancelled off. You're only left with the cos x. You're only left with the cos x. Therefore, from number 11, differentiate of sine go to cos. Number 12, differentiate of cos go to negative sine. Okay, d dx of cos x. From P1, we learned about cos x can be written as sine of 90 minus x. Okay, there is a differentiate of outside inside here. The outside is sine, the inside is 90 minus x. So differentiate of outside sine equal to cos. Differentiate of the inside. Differentiate of the inside 90 minus x, you get a minus 1. Therefore, we get a negative of cos of 90 minus x. If we go back to P1 again, cos of 90 minus x is exactly sine, so negatives of sine x. Therefore, you can see from here, number 12, okay, your differential of cos go to negative sine. By referring to these two together, there's something interesting that we can follow. You can see that sine differentiated go to cos, cos differentiated go to negative sine. Okay, since negative is a multiple, differentiate of negative sine go to negative cos. So negative cos, if you differentiate back again, you go back to sine. So it becomes a cycle. Okay, it becomes a cycle that you actually can follow. So following this cycle, you have a differentiation. If you reverse the process, you will get an integration. Okay, number 13. Okay, differentiate of tangent. Okay, tangent here from P1 we will read as sine x over cos x. Okay, sine x over cos x. Then this one will be following the quotient rule. Quotient rule, where is quotient rule? Quotient rule will be rule 6 here. Okay, then we actually get that we can use rule 6. So differentiate the top, keep the bottom, minus keep the top, differentiate the bottom over the bottom square. You realize that you have a cos square x plus sine square x on top over cos square x. the top part, the sine square plus cos square, this is a 1. Therefore, this is read as secant square. 14. 14, we have a differentiate of the secant. Okay, so we differentiate the secant. So the dx of secant x. Okay, so we can read it in the form of 1 over cos. Okay, so we can use quotient rule if we want to, because since this is in the form of fraction. If I don't want, I can write them as the outside inside. This is cos x power of -1. Okay, then from here I differentiate the outside, bring down the power minus by 1, multiply by differentiate of the inside. Okay, so you will see that after simplifying, I have a sine x over cos square. So by rearrange them, you have a secant x tangent x. Okay, this will be 14. So you can see that the differentiate of the secant x go to secant tangent. Number 15, cosecant. Okay. Number 15, differentiate of cosecant. Okay, so cosecant defined as 1 over sine. Okay, earlier we already demonstrate the how to use differentiate outside inside. Maybe this one we go back to quotient rule. Okay, so differentiate the top, keep the bottom, minus keep the top, differentiate the bottom, over the bottom square. So you will see that this 0 times this go to 0, so you only have negative of cos x over sine square here. That actually give you negative of cotangent x cosecant x. Okay, so number 15, you can see there's a cosecant x cotangent x. Number 16. Number 16. So I have a cotangent x. Okay, so cotangent x, we will read it as cos over sine. Okay, so this one we just apply the quotient rule, differentiate the top, keep the bottom, minus keep the top, differentiate the bottom, over the bottom square. So let's see what we get. So I have a negative of sine square x minus cos square x over sine square. So you can see the top will become -1 over sine square. So 1 over sine is cosecant, so you have a negative of cosecant square x. Okay, negative of cosecant square x here. Then after that, okay, you have rule 17. Okay, 17, so you have a dx of arctangent of x. Okay, you need to know how to do this. Okay, this to prove this, you have a similar approach as number 10. Okay, we let y thing. Okay, let the y working. So we let y equals to arctangent of x. Therefore, you have x equals to tangent of y. So I do d dy for both sides. d dy for both sides. Okay, so you will get a dx dy. Then the tangent become a secant square y. How do we know this? This is actually from the rule 13. Okay, we have the rule 13 here. So this only helps us to get dx over dy, but what I want is dy over dx. So I flip them upside down. So I have 1 over secant square y. Okay. Somehow from the questions, from the formula, you get 1 over 1 plus x squared. Okay, 1 over 1 plus x squared. Therefore, over here, I need to change it to something else so that I can actually get 1 over 1 plus x squared. So we refer back to trigo formula. The secant square can be written as 1 plus tangent square, y. And the tangent y is actually x from here. Therefore, it's a 1 plus x squared. Okay, So over here, you have these questions. Okay, so the best is to let you practice this uh, 17 formulas first. So we will look at the questions. Okay, we shall look at the questions. Let's see, questions. Okay, questions. Okay, wait for a while. Question is coming up. Okay, so from this rule, okay, you have to get used and able to recognize what are they, of course. Okay, you have to recognize the rule. Okay, and apply the formula. But the only bad thing is the rule 17. Okay, the rule 17, as I say, is fall under the new syllabus. Therefore, you don't really have that in the old past year questions. Therefore, we will need to use or we only can use question from the textbook. Okay, let's see what do we get from the textbook. Okay. Okay. Let me get something from the textbook. Very fast. Okay. So very fast. Okay. Okay. So from here, okay, with all the different formulas that we have here, okay, we have section A, section B, section A, the basic rule, section B, basic differentiation. You can actually copy these 17 rules in your list of so that you can actually easily memorize them. Okay, then the rest is all just application, how to apply the rule. Okay, you have the mixed questions and you have the question for the rule 17. Okay, so okay, we still have two parts for the differentiation. Okay, part C is called parametric differentiation. Parametric differentiation. Okay, part D is called implicit differentiation. Okay, so together we for this topic we have 4 sections. Okay, now you can actually start trying to the questions. Stop recording.